Good afternoon,
Good
everyone.
afternoon, everyone.
I'm excited to
I'm
welcome you
excited to
all for the
welcome you
very
all for
first
the
day
very
of our
first day
computer
of our
science
computer
bootcamp.
science camp.
Over the next
Over
three
the
days,
next three
we'll
days,
explore
we'll
critical
explore
areas
critical
of
areas
computer
of
science
computer
teaching.
science teaching.
Our goal is to
Our goal
empower
is to
you
empower
with
you
practical
with
knowledge
practical
and
knowledge and
strategies that you can
strategies that
apply
you
in
can
your
apply in your
classrooms.
classrooms.
Today,
Today,
we have two
we have two
interconnected
interconnected
sessions. The
sessions.
first one
The first
begins
one
now, and
begins
the
now,
another
and
one
the another
will
one
be at
will be at
4:30 p.m.
4:30 p.m.
Make sure that
Make
you are
sure that
tuning
you are
in for
tuning
both
in
the
for both the
sessions.
sessions.
Our today's
Today's
focus will be
focus
on
will be on
making our
making our
students
students
future ready
future
and
ready and
empowering
empowering
teachers for tech
teachers for
driven
tech-driven
classrooms.
classrooms.
You will be
You will
learning
be
more
learning
about
more about
computational skills,
computational skills,
problem solving
problem-solving
techniques,
technique,
and also
and
learning
also
about some
learning about some
strategies related to
strategies
lesson
related to
planning
lesson
to
planning,
enhance your
to enhance
teaching
your
and
teaching
inspire
and
your
inspire your
students also.
students also.
Now,
Now,
I am
I
honored
am
to
honored to
introduce our
introduce
speaker
our
for the
speaker
day,
for the day,
Ms. Deepa
Ms. Deepa
Bhandari.
Bhandari.
She is a
She
renowned
is a renowned
educator with over
educator with
25
over
years of
25 years of
experience,
experience,
currently a
currently
computer
a
science
computer
teacher,
science teacher,
Mata Jaikaur
Mata
Public
Jaikaur
School
Public
in
School
Delhi.
in Delhi.
She is also
She
a
is also a
royalty-based author
royalty-based
with
author with
Extant
Extant
Publishing.
Publishing.
Ms.
Ms.
Bhandari's
Bhandari's
innovative
innovative
approach to
approach to
computer science
computer
teaching
science
will
teaching
provide
will
us with
provide us with
invaluable
invaluable
insights for
insights for
everyone.
everyone.
Over to you,
Over
ma'am.
to you, ma'am.
A very big
A very
thanks,
big thanks,
Estran.
Estran.
And
And
Ma'am, we can't hear you.
yeah, there is a lot of echo. But am I audible very clearly? I would love my audience and my fellow co-educators to please let me know if is my sound resounding as well.
Yes, ma'am, it's audible.
So it's audible. Okay. Okay. So before I begin with the session, I would like to just spend 2 or 3 minutes in talking a little bit about my experiences as an educator. Um, I have been a computer science educator in Delhi since the past 28 years. And in my tenure as an educator, I have seen the progress of schools across Delhi, schools across NCR, and schools pan India rather, through the medium of conducting workshops and training sessions. The kind of paradigm shift that we have had from DOS-based systems to Windows systems, and now with the advent of AI, the world and our education system has indeed come a very, very long way. And having said that, it is so important for all of us to continuously be on a path of progress as fast as the progress in our fields. You know, there is a very famous saying about computer science teachers that all other teachers, they become better and seasoned with time, but computer science teachers have to always be on that progressive path of renewing themselves, upgrading themselves, and keeping abreast with the latest. And it is with this pedagogical mindset that I am here to conduct a very small session on ways and means of how we can increase the coding quotient of our students. So, um, before I begin, also, if I can have a hand raised from all the listeners of this webinar, all the attendees rather, uh, who have been around for more than 10 years. If I can just have a hands up, because I love to know my audience a little better. You can give me a reaction or something if your answer is yes. If you are able to, hear me properly, I'll also get to know that. And I would like to make this session a little interactive so that it doesn't get really boring and we all come out of this session a little wiser. So, yes, I see a lot of people who've been around at least a decade, if not more. And so, this is the time that we bring back a lot of coding mastery. If you remember, till a decade ago, or maybe more, the entire focus of a computer science teacher was always coding. And it changed there was a paradigm shift when we started creating users more than developers. Our focus changed into teaching children how to paint and draw in their primary years. And we progressed to uh, telling them about operating system, how to use Windows accessories. We progressed into the realms of, office applications like, Word, Excel, and PowerPoint. And we would start coding only in the later years with QBasic and things like that. That was not how things were many, many years ago. Many years ago, when the graphical user interface was not even in the picture, the entire focus of computer science educators was coding. So we started with Logo as the first coding language in the beginning. And I'm sure all of you here, who are all those who raise their hands and have been here more than 10 years, they will agree that those were the times when we were instilling coding in our children. So those times are coming back, but with a bang and with a lot of changes. So allow me to start presenting a little uh, PPT that I have. I'm not sharing a lot of graphics with you, but an outline which will allow you to, uh, you know, uh, follow the points that I'm taking up during this session. So again, I will need a thumbs up the moment I start sharing. So I hope that, uh, sorry, I just stopped share. I think that was not the proper way of sharing. So is my screen okay with everyone? Do let me know in the chat.
Yes, ma'am.
Yeah. All right. So, uh, building future ready students. With a lot of focus on increasing the coding quotient of our dear students, I'm here going to primarily target students from classes 4th to 10th as a median, as a central point, because in classes 11th and 8th, we have a very rigorous curriculum which we are all following. And the pre-primary is the primary and the foundational levels are too non-specific at this point of time, especially where the Indian education system is concerned. So I will begin talking about, like from middle school levels. Just a, just a second. I'll just take a minute. There's a little technical glitch here. Yeah, good to go. Really sorry for this. So as we delve today, um, into building future-ready students. Let us focus on how computational skills like coding and problem solving can equip our students for this rapidly changing technology landscape. So, this session, as was mentioned in the description, dives into how computational skills like coding and problem solving equip students for the rapidly evolving techscape. And our key takeaways for the session are to think like a coder, simplify complex problems, talk about industry skills, coding, AI, and automation, the real world impact, applying tech to everyday solutions, future trends, staying ahead in tech, NCF 2023, how it infuses tech into education. These were a bunch of things that we had planned for this particular session, right? So I would like to begin by asking you a question. And the question is a very simple one with a very obvious answer, but still it is imperative that each one of you gives me an answer for that. And the question is that do you think that coding, computational thinking, and technology education in schools that we have compares to the industry requirement, or do you think there is a gap? Do you think we are able to produce children uh, which the world of IT industry needs? Are we there? Are we able to give them what they need? That is my question. Absolutely correct. We have teachers from DPS, Miyapur, and we are definitely not there. We have Mr. Abhishek Pradhan saying there's a very big gap. There is absolutely correct. There's a very huge gap. And that is one gap which I know my fellow educators and we think alike. And this is the gap that I wanted to address today. This gap. So if I actually talk about, if I'd like to show you my slides. So the Indian education system versus industries, coding and IT needs are way apart from each other. In fact, there was a team of IIT and IIMs. They created a non-government organization, not-for-profit organization, and they also created, a whole group of pan-India computer science educators way back, way back more than 10 years ago, and they tied up with the industry bigwigs and they focused on what computer science curriculum in schools should be. And we have still not reached there. You people are absolutely correct. And that is the gap that we want to bridge here through this webinar on what we as computer science educators, हमारे हाथ में क्या है? What can we do to bridge that gap? So if you talk about the current state of Indian school education, we have a traditional curriculum. By traditional curriculum, that is not something wrong. I am very proud that we have a traditional curriculum. However, the Indian school curriculum has focused and on the grassroots level, it is still more on rote learning. And when we talk about rote learning, we are still talking about exams. We are still talking about children have to be prepared for to do something. They are not able to do something extempore. We even subjects like maths and science are taught with emphasis on memorization more than practical application. There is very limited exposure of technology, and largely this is because of the gap in infrastructure. There are only very select few private schools which are providing state of the art technology. Very few government schools in Delhi are providing state of the art technology. However, we see that there is a very limited exposure to technology if we talk pan India. Absolutely right. Absolutely right, Miss Khyati. And this is one of my points which is going to come on my screen very soon. Skill development and project-based thinking is just not there in our education system. There is also a dearth for teacher training. If you look at the B.Ed and the M.Ed curriculum, they do not utilize technology properly. And I'm glad that you are all there the baton and the entire burden is on your shoulder of the technology requirements of the industry. I mean, whatever you are doing is human service to our nation, because there is a very little, support system that we are getting from our policymakers. However, when we talk about the industry requirement, and I'm sure that all these people will give me a very good response to when I talk about industry requirement. So, uh, the industry requirement, they want a lot of practical coding skills. They want people to know about emerging technologies. By the time we are training our children on a certain version, on a certain app, and we are able to just touch base for a certain while, by the time they graduate from schools, they are not able to. And one of the major issue with our policymakers is that even for a computer science engineering degree, I need to focus only on English PCM. Even if I know as a student that I want to become a computer science engineer, I will not focus on computer science as a major subject in 11th and 12th, because ultimately it is the entrance examination and my score in English PCM which will land me into the right spot. So this is such an irony. And you know, so yes, you are right, Meenal ma'am. There are students who find coding very difficult, and that is because our education system has conditioned them not to apply too much of their brain. They are still doing a lot of they're still doing a lot of rote learning. So soft skills requirements are there. If I talk about soft skills, along with technical skills, the industry values a lot of soft skills, such as critical thinking, creativity. We know it as 21st century skills. So, creativity, collaboration, communication, these are skills which are which we are still not able to imbibe in our curriculum. So, please feel free to not agree with me on any of the points, and please feel free to put it in the chat box. It is always good to have the other point of view as well. Um, so there is a huge gap. I think that there we have gone unanimous that there is a huge gap and there is a huge need for bridging this gap. And thankfully, I'm sure all my fellow mates know about the NEP 2020, the policy, and the National Curriculum Framework 2023. They realize there is a gap. They realize that the times have changed, and they realize that additions need to be made, and there has to be IT and tech inclusion in anything that we do now. So one of the major points where NEP is concerned is the inclusion of artificial intelligence and coding. There's a lot of things that CBSE schools are doing. Then we have the adult tinkering lab for, concept, and I know that our great publishers have also streamlined a lot of sessions for you. There's a whole boot camp, and AI will also be taken into great details. Yes, Shalini ma'am. Unplugged activities. You've opened my bean bag and you've let out my secret. So yes, introductory unplugged coding activities, even when we do it in grade one, uh, to explore directionality, sequencing, critical thinking, and problem solving. Thank you so much. It is so heartening to see that all of you are so progressive, and so you know exactly what I'm going to talk about as well. Good. You should also be interacting more with me in the chat box. So if I go into the details on NEP and NCFC, where coding and technology is concerned, here are the main takeaways, and you may be wanting to take a screenshot of this, but we have already decided to give you a handout because it is important for all of us to know exactly what the NEP and the NCF have in store for us where coding and technology is concerned. So you know at the we will start with the main ideology. The main ideology is that there has to be integration across all stages of education. So NCF aims to integrate technology and coding across all stages. If I talk about the foundational stage, there is focus on play-based and experiential learning with the introduction of basic computational thinking. So, as Shalini Bharat ma'am just said, uh, unplugged activities. I'm sure that you all know about code.org. If you just type on Google, if you just make a simple search on code.org and download the PDF that they have for educators, I think it is a must have, because there you have graded activities for the foundational stage, for the preparatory stage, for the middle stage, for the secondary stage. They have a plethora of activities. You have offline and online activities, and you will not believe the kind of activities that they have. And my first reaction to code.org's activities was, why to go in for unplugged coding activities? सीधा computer पे कराओ ना. बच्चों को लाओ, like bring them to the. Are you people okay if I use a little Hindi in between? I do not know from which parts of India you are, so I'll stick to English anyways. So yes, Bhumi, I will repeat. If you go to code.org and if you download the PDF that they have for educators, code.org is a product of leading tech giants, and they have this corporate social responsibility of giving a lot of focus to coding. So code.org is the standard Bible of all coding platforms. And code.org provides a lot of interactive activities to enable coding and to increase coding quotient of our children. And that is completely free of cost. And if you look at that platform, yes, Nishita ma'am, for block-based programming, not only block-based programming is a very good method of introducing coding to youngsters. You thankfully we also, the MIT people have also introduced Scratch Junior, which we have included in class 2 level of our S-Chan books. If you look at our books called Cloud, they are the latest addition to the S-Chan series of computer books. Even our term books have Scratch Junior block-based programming, even at the grade 2 levels. So if you talk about integration across all stages, what is it's like, middle and secondary stage to hamesha se tha. But if you talk about foundational and preparatory stage, it was a big question mark even for me many years ago when I got connected with code.org, that how come they want us to initiate uh, coding at the age of 3. But yes, and you must all have heard of this student. Um, yes, pictoblocks.ai. You have Google ka Blockly. You have a lot of wonderful coding platforms which have, even for foundational and preparatory stage, they're doing robotics and they're doing AI with the tiny tots. And if you, Blockly, Hiba, absolutely correct. Code Monkey is another platform. So these are all platforms, and then you have those physical computing platforms, like you have Make Code, you have the Arduino board, and you have the Raspberry Pi. Um, so that these are wonderful things. And if you look at foundational and preparatory stage, and coming back to uh, what we were talking about offline activities and coding. There is a huge scope for that in the school curriculum. And usually we have a class teacher system there. And we must, as computer science educators, because we have 1 or 2 periods in a week, and there is uh, certain relaxation that we have in our hands. We are in fact lucky that there is no prescribed curriculum by the board as yet. So there is no prescribed syllabus for class 1 or class 2 or for nursery, for 3 years old or 6 years old. So that is in fact good for us, because then the baton is in our hands. And we are the ones who have to inculcate coding mastery. The sooner we begin, the better it is. But then there is a clause. We need to begin sooner, but in the right. And what is the right way? The right way is to talk about computational thinking. You need to make your students think like a coder. Am I right here? Do you agree with this statement? And what do you understand of it? When I say make your students think like a coder, uh, what do you understand from it? Anybody would like to answer this question? Um, if I say that I'll reframe my question that if you want to make your students think like a coder, what does it actually mean? So we all know that yes, this statement is absolutely universally correct. We must do it. But what does it mean and how to go about it? Let us delve into that part. So this is the second part of my first session. Make your student think like a coder. Yes, Madhuri ma'am, you are absolutely spot on. We are talking about programming, logic, and techniques. We are talking about problem solving. So I'll throw a question, or I will create a. Okay, I'll tell you what I do in my class, typically in grade 6. Okay, so I'll tell you what I do in my class when I start talking about problem solving techniques. Yes, Bhumi ma'am. I'm talking about problem solving. Yes, Khyati ma'am, and logical reasoning. So I throw problem solving questions to my class. I'll give you an example. Okay. So example is I have 8 balls, and you can use the same example for your class. I have 8 balls. They are all exactly same red in color. They're exactly the same. They are exactly of the same size. With my eyes, I cannot make out any difference between these balls. Each ball weighs 20 grams. However, there is only one ball which weighs 19 grams. I'll give you a beam balance. Tarazu, I'll give you a beam balance. Now you have to solve the problem. You have to find out for me which ball is the lighter one. So I throw this question to the class. Absolutely right, Shalini ma'am. This requires thinking out of the box. So if I pose a riddle like this to my class becomes very, very interesting and my purpose gets solved. And very typically, the answers I get are like this. One child will stand up and say, ma'am, we can weigh each and every ball and then we will come to know which ball is the lighter one. Excellent. So you take 8 times you weigh these balls because there are 8 different balls and you are able to tell me which one is the lighter. Very good answer. Can somebody give me a better answer? Very good, Madhuri ma'am. So we can take one ball and compare each ball with it. Absolutely right. That's a very good answer. So if I have one ball, I will take 7 chances. Maximum, I will need 7 chances to find out which is that ball which is lighter. Because there will be 7 other balls which I will keep one by one on the other side. Very good answer. So from 8 tries, we have come to 7 tries. Great. Now we have Khyati ma'am thinking very, very logically with all her computational abilities. We will divide the ball into 2 sets and keep decreasing the list. Absolutely right, Sonam ma'am and Khyati ma'am. So we'll take 4 balls on both the sides. Now one side will be lighter. Then we will divide the ball into 2 sets. Then one side will be lighter. Then we will divide the ball into 1 set each. Then we will come to know exactly which ball is lighter. So 4, 4, then 2, 2, then 1, 1. So in 3 times, we are able to find out which is the lighter ball. But can anybody give me a better answer? Absolutely right, Abhishek sir. We are talking binary here. Yes, we classify by error and trial. That is also one way of doing it, where we have randomly, we do it with error and trial. Then, yes, binary sorting is one way, which we've already discussed. Can somebody talk about doing it in lesser? The elimination method also we've already discussed. So another method is to take three balls. Now, either the two sides will be equal. If that is the case, then from the remaining two balls, I will be able to come with the lighter ball. And with this method, within two tries, I will be able to definitely find out which ball is lighter. So these are very, very interesting puzzles and problems that we can pose to our class. So, instead of focusing more on talking about history of computers or talking about, uh, using a computer, like we talk about using an app like Word, Excel, PowerPoint. Of course, these are also very, very important. Yet, we need to streamline in our lesson plans and we need to talk about problem solving methods also. The class becomes very interesting. We open up the mindset and the thinking of our children, and we are able to achieve out of the box and creative thinking with collaboration, with teamwork, with project work with our children. I will now quickly run through the different steps of problem solving with you. And these are, as you can see on the screen, I'm talking about decomposition, pattern recognition, abstraction, algorithm design. So let me just quickly run through problem solving techniques here. When I talk about decomposition, as you all must be already aware, decomposition is the process of breaking down a complex problem into smaller and more manageable parts. This technique helps students understand the problem better and they develop step by step solutions. So, for example, if a student is tasked with creating a website, can you please break it down? Can you please decompose this problem? As a student, I have given you the task. You are a student. I have given you the task of creating a website for the school. Using decomposition, how will you break it down into smaller problems, into smaller tasks? So, can I have some answers there? Great. Yes, Nishita ma'am, you're absolutely right. So, first we will, finalize the website design, and different web pages are the different way, the different parts of my decomposition. So, then another way, yes, Anjali ma'am, absolutely right. Yes, Madhuri ma'am, we can create different menus. I also completely resonate with what Meenal ma'am has said, and I think what Meenal ma'am has said makes more sense. First, we will make a blueprint. Let us first make the concept. So one person makes the concept. I have a team. Absolutely right, Khyati ma'am. Then you gather all the information. And yes, Anjali ma'am, the blueprint. So first we create the concept. So now I finalize that for the school website, I need a page which is about us, about the management, staff, principal, and everybody. I need a page about academics. I need a page about events and activities. I need a page about how to get admission into the school. I need a page about infrastructure and facilities, the mandatory disclosure. So first I will create a concept. So we as adults are already doing it. But when we do it as a class activity, this is a very good class activity that you can do when children are not going to their labs, you know. So we can talk to children about decomposition and we can pick up activities like this. So I divide my groups into 6 parts and I give them 6 different activities, 6 different problems to solve, bigger problems, and then I ask them to break it down into smaller tasks. And definitely the children will understand that when I make smaller tasks and I achieve one task at a time, what seems to be a huge problem becomes very doable. So this is the problem solving technique that we need to tell our students about. Next, we come to pattern recognition. As you all know, pattern recognition is a very important part of coding. We need to understand and analyze patterns and we code accordingly. So whenever we create iteration loops and sequencing, we always look at pattern recognition as a very important part of coding. So recognizing these patterns can help, and there are a lot of pattern worksheets that children do in their pre-primary stages, in their foundational stages. We can have higher pattern solving and pattern recognition. There are books that you will find. There's a lot of material on internet that you can get on pattern recognition. So please do take up pattern recognition exercises with your class, whatever their level be. So with complex pattern recognition can be done in middle and senior levels, and simple pattern recognition can go in our, primary levels. But that has to be included as a major part of coding. Then you have abstraction. Is there anybody who can tell me that when I talk about abstraction in terms of coding, what does it mean? What what am I trying to say when I say abstraction? If you people want, we can do a webinar on each of these aspects. I can talk about an hour and discuss exactly in every class how can we do these activities. So maybe some other time, and if the people at S Chand are making note of this, if we get such a feedback, I would love to do webinars, more webinars on all this. And we can actually create a lot of content which will be ready to use in their classrooms. These are webinars that we have not had as computer science educators. Yes, Pallavi ma'am, hiding the unnecessary part. Absolutely, ma'am. So when I talk about abstraction, it involves on focusing the important information only and ignoring irrelevant details. This helps in simplifying the problem and finding a solution more efficiently. So, if I have to give you an example, suppose I've asked a child to code a game, then the student cannot get bogged down with graphics. Graphics is complicated. Uski hum baat nahi करेंगे. Let us just talk about the coding part of the game. That is relevant for me. That is relevant for my student who needs to learn how to code. The graphics part, the UX, the UI part, the user interface part, at that point of time is not necessary. I'll give you an example. English teachers and language teachers do it all the time. You know what language teachers do? When they want to check spellings, they will take a dictation. When they, want to talk about searching and skimming, they will give you an unseen passage. When they want to check your creative abilities, they will give you paragraph writing. So they focus on one objective at a time. This is exactly what we do when we do abstraction. When we do abstraction, we are just focusing on what is important and we just don't bother about what is not important. And abstraction is a technique that enables us to just focus on, that famous mythological tale of uh, Lord Arjuna. When his guru asks him, "What do you see?" He says, "The eye of the fish. That is my only purpose." So what he was actually doing was abstraction. A mythological example of abstraction is this, that do away with irrelevant details and focus on what is important. Algorithm design, of course, we will be doing it in the second session as well in details, is a step-by-step procedure for solving a problem. Now, we always focus on algorithm design in our classes. I think we are all doing it. Is there anybody who doesn't do algorithms with their children in classes? there has been a shift. If you've been a seasoned educator like I have been here 28 years, I have seen algorithm chapters have been introduced in mathematics curriculum, then they were taken away from mathematics. Algorithm was the central point of what we used to teach 10 years earlier, flowchart and algorithms, programming logic and techniques. And now we see that there are a lot of people who have stopped looking at algorithms. But here with this session, I would like to please reiterate and reinforce that algorithm design is absolutely necessary. And yes, the trend is changing and we need to get it back. There are some things that we need to retain, and algorithm design is one of those. So, having talked about step-by-step approach of algorithms, we now move on to, you know, real-world applications. We see coding being used in various fields, whether it is healthcare or finance or education. And the skill of coding, which is the best part. And I hope you all agree that coding and problem solving is not only specific to the world of computer science. We apply the same logic and the same behavior when we solve problems in our everyday life, be it physical, be it in the emotional realm, the social realm. Problem solving is an all encompassing pedagogy that that must be transacted in classrooms. It is applied everywhere. Absolutely correct. We also need to talk about future trends and how staying ahead with continuous learning and by embracing new technologies is extremely important. So, if I talk about uh, emerging technologies, I cannot not talk about artificial intelligence, coding, and animation. So, there is one burning question in the minds of all educators, all computer science educators, especially. And that burning question, correct me if I'm wrong, that burning question is I can go to ChatGPT and I can ask ChatGPT to make a code for me. Then, how do I ensure that my child learns how to code? So, do you think this is a very relevant question and a very relevant problem in front of us? And I think every teacher is facing that. So, if even an English teacher would feel, how do I ensure that my child learns how to do creative writing? My child goes back home, opens ChatGPT, and writes the paragraph and writes the essay. How do I tackle this huge problem? So, yes, this is a very big question in front of us. We are glaring at paradigm shift in our education system, in our roles as educators, and in our very, very questionable, curriculum stages because of ChatGPT, because of AI, because of millions of these AI websites which are, doing things free of cost for the whole world. So, have you thought about it? And can you give me certain answers to this? And then I will talk to you about how I have researched this topic and how in times of AI we need to bring about a change where coding is concerned. Yes, Meenal ma'am. We were made to sit in the lab and on a computer where there was no internet connection. We were given a task and the children had to solve the question there and then. That is a wonderful way, Meenal ma'am. That is an excellent way of ensuring that our child learns to code. When you have assessment techniques, just like Meenal ma'am said, when you have assessment techniques where the children do not have the power of AI in their hands, and you ask them to build a code and check and see if it is working. That is going to ensure that coding goes at grassroots levels. Absolutely right. Also, I'm looking for another very holistic answer, something which is more broad-minded. Yes, this is always there कि chat GPT को उनके आगे से हटाओ and make them do an assessment. Okay, Mr. Karthik, can you elaborate a little bit on this? He's saying that coding is there as a template, and then we have to learn those templates individually. Um, okay, so maybe I need a little more understanding of what you were saying. I'm so glad that you are all interacting. It is so heartening to see that. An interactive session is always good because even I get to learn from what you are saying. So I would love if Karthik sir, if you could just elaborate on what you're trying to say on the chat box. So I'll come back to what I meant. Now I am of the mindset. I don't know whether it will work or not. I still have to try this in my classroom. But I am of the mindset that we need to embrace ChatGPT. If I were an English teacher, I will accept that my children have ChatGPT. And I would like to use ChatGPT together with them. So even if you have ChatGPT, you need to extract the right thing out of it. So your skill sets that you need to impart in class will be different. You may not want them to do creative writing in the class. You may ask them to create ChatGPT prompts which will create very specific answers that you want. In the same way, when we come to coding, when we talk about coding, okay, we will talk about using ChatGPT to create larger levels of coding, which we will not be able to do in our classrooms otherwise on a normal day. So I think if I look at the industry standard, I mean, not the industry standard, the education standard. Usually we start scratch in classes 3, 4, right? We move on to Python. There are some very progressive schools. They begin Python from grade 6 onwards. There are other schools that do it in 7th or 8th. Then there are many schools who touch Python only in classes 11th and 12th. But at in one level, we are able to talk about variables, input, we talk about conditionals, we talk about iteration. I think that's about it. Before the senior secondary level of classes 11th and 12th, we are not able to go beyond it. But now think about it. If my children have chat GPT, I can progress very, very fast. Now I don't have to bother much about the syntax. My children will not have a syntactical error because they have ChatGPT to refer to. But now we can, with the advent of AI, increase the coding quotient and bridge the gap. The problem that we were facing in the beginning of aspecting the gap between what the industry wants and what the school is giving to the child, can be done with the use of AI, given the paucity of time that we have. With this, I come to the end of session 1. And because we need to also look at a question answer session. So although this session has been hugely interactive, and yes, Meenal ma'am, there'll be no errors, or ChatGPT can assist them in, taking out their errors, and they can focus more on understanding and reaching higher levels of coding. I remember that when I was a child and during my times, when we used to do coding, we used to reach the level of recursion. And till this date, up till class 10th, I have not been able to, in my tenure of 28 years, I have not been able to reach coding to that level with my children. I remember I had to give an answer on Towers of Hanoi problem when I was in class 8th in my school. And that was donkeys years ago. Because that time we only focused on coding and we need to bring those times back. So yeah, in exams, students are not able to write code during the exam. So maybe we need to reassess our children in better ways in more interactive ways. Maybe our coding exams should be more practical oriented rather than in theory. Of course, during the theory exam, they need to give a class 10th exam. But I'm so happy that if you know about artificial intelligence as the CBSE, the exam that they take, it's only a 25 marks theory paper. So things are changing, and we as very progressive educators can leverage the right way of coding in times of AI and increase the coding quotient of our children. So, yeah. So if we have an open house for any other question and answers, and I will request Akanksha ma'am to please help me with this. Yes, ma'am. MCQs, and this is exactly what NEP says. Meenal Arya ma'am says that we can focus on a lot of MCQs. MCQs hit the concept very hard. Ironically, children think MCQ it's very easy. It's never easy. There is always scope of hitting the nail with MCQs, and that is where you should download and use the competency-based learning manuals which CBSE has. If the team at Eschan wants, I can take a session on competency-based learning as well, and where we learn how we can use MCQs very effectively to ensure that the children learn the nuances of a concept, whether it is physics, chemistry, or it is computer science, coding, whatever it is. You can use the power of competency-based learning. So over to you, Akanksha ma'am, if you're there,
Yes,
and
ma'am.
and if you
So,
can lead, if there are any questions, maybe you would like to moderate and then I can answer those
sure,
questions.
ma'am.
We still have 7 minutes left to the session for
Right.
an open house.
So all the participants, if you have any questions related to the session, you can post it in the chat box and we'll take them one by one.
Okay, so since this has been a very interactive session, we probably don't have a lot of questions to
Hmm.
answer, but then there is one particular question which I did answer, but I think I'll elaborate on it. And that was that was one contention, one bone of contention that someone had. Just a minute, let me just go and find that out. I'll just take a minute. I think somebody said that children are not able to create codes on paper. Theoretically, they are not able to uh, score much where coding is concerned. Yeah, Nancy ma'am asked this question. She says, but in exams, students are not able to write their code. So, to elaborate on that aspect further, I would say that taking more of coding exams in practicals is going to really, really work. That is one aspect. And so, if we are talking about practical assessment of coding, we will be able to see, and then children will focus more on, they'll ensure that their code works. So, usually, what happens in school is that we bring the children to the lab for a session and we talk about the code with them. We tell them the code, they practice that code on the computer, they run it and see it, they execute the code and see it. So, let us do it the other way around. If you have heard about the flipped classroom concept, send them a video in a WhatsApp group teaching them about the code. So suppose I'm talking about the leap year code, which is very typically what we do, or a code about finding the total grade and remarks based on certain conditions. So discuss the code and talk about the code with them. Teach them about the code at home, like give them that as homework. So that's a flipped classroom. Usually we take up the concept in the classroom and we give them homework. Now we'll do it the other way. As homework, we will give them the concept video. So they will look at the concept on their own, at their own pace at home. And then when they come in the lab, we will ask them to create from simple to little complex codes. So now we have taught them the theory at home. Let them come to the class and focus more on the code. Focus more on the practical. Don't utilize your theory period in teaching concepts. In you can't always have a flipped classroom, but you can sometimes use certain new transactional methodologies to focus more on building code rather than teaching the theoretical aspect. So that is my 2 cents on the question asked. And I think there
I have
are
one
also
more
some.
question, ma'am.
Okay.
Uh, we have a question which says, can you name a few competitions regarding interest creation in coding?
Creating an interest in coding.
Yeah.
So I think, as someone said, I'm forgetting the name, I'm so sorry, but somebody during the course of the session was talking about block programming. And I think the power of block programming is still untamed. Children can create animated lessons. They can create their own games just by going click, 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 click. And MIT people have a huge resource. They have a huge resource of game development, animation development, text animations. There are schools which are conducting inter-school competitions on how children can, learn a lesson in EBS and create that animation using Scratch. So, like we discussed, we have Scratch, we have Blockly, we have so many. And please explore Minecraft. That is also an excellent platform where children can, so we have game-based learning as a very great pedagogical skill, which has been recommended by NEP as well. So, gamification and game-based skills. Now, imagine that this is a perfect multidisciplinary activity for our lesson plans, where we look at one aspect in another subject and a child creates an animation using, an animated tool. So what happens here is that as computer science teacher, when I am teaching a child how to code, my focus is in teaching how to code. So that becomes boring for certain children who are not interested in coding, right? But when my focus is on create an animated joke or create an animated lesson, so now the child needs code to achieve that purpose, and he is very interested in doing that, in creating an animation or creating a car racing game. They would love it. They will go to any extent and sit for n number of hours to create a game. Believe me. So you are teaching coding as a byproduct. That is why we are in the times of block programming. So I think you can begin with that. And once the child achieves block programming, then throwing problem sessions in the class will make the class interactive. Like I took the example of 8 identical balls. So when you are throwing challenges and you are throwing problems in the classroom, they will definitely interact with you more, and they will use code. And give them homework based on ChatGPT. Let them learn how to create code with ChatGPT. What will happen is the initial hitch of certain children who are not mathematically inclined. So when they are not able to, use mathematics good enough or coding good enough to solve your problem, they get discouraged. When you give them ChatGPT, they will feel we can also do it. So ChatGPT will give you the power of inclusion in the classroom, and you will definitely be able to find ways and means using AI to make your coding classes more interactive.
Thank you so much, ma'am, for sharing your valuable insights about the topic. But all the participants, thank you so much for your active participation in the first session. But do remember, this is just the beginning. Our journey through this mastery still continues. So
Correct.
stay tuned. We are going to resume back at 4:30 p.m. with another session with Ms. Deepa Bhandari. So let's take a short break, refresh ourselves, and get ready to join us again at 4:30 for the another session. I'll
Thank you
see you
so much.
all at 4:30. Thank you so much,
Thank
ma'am.
you so much. Thank you, everyone.
Thank you.